Welcome. So in this lesson, we're going to be talking about measuring angles in degrees and radians. Now, before we launch into the notes here, I actually want to go through a little bit of a PowerPoint presentation just to kind of situate us. You don't have to write anything down, so just sit back and enjoy. Okay, so the first question we're going to ask ourselves is why degrees? Why do we use degrees? And more specifically, what we could ask ourselves is why are there 360 degrees in a circle? Why is this true? And, there are certain responses to this. Some people might say, well, it's the Babylonians. They really like the number 60. So they kind of used that when they were thinking about it. Or you might say, well, it has to do with the fact that it takes the Earth 360 days to go around the sun. That could be another good reason. What you notice about all the reasons why there is 360 degrees in a circle are they're very human-centered. The Babylonians, the time it takes us to go around the sun, they're all from our perspective, very human, not very objective at all. So the next question we should ask ourselves is, as mathematicians, is there something more objective we can use? And although we wouldn't say it's better in any way, but just another way of doing it, which you could argue is more objective, is to use something called radians. Okay, so what are radians? So if I have a circle, and here is the radius right here, this radius, let's call it r. What I can now do with this radius, so this length here, I'm just going to draw the same length up here as well. So this orange section here is also r. And now what we can say is that this angle right here is 1 radian. We have a definition. 1 radian is the angle subtended at the center of a circle by an arc that is equal in length to the radius of the circle. So that's the definition, and hopefully that makes sense by looking at this visual here. Now what we're going to do is we're simply going to keep on adding radians right around until we get all the way around this circle. So as you can see, we have 2 radians now. Now we have 3 radians. And let's see how much more we would have to add to get halfway. And we would have to add 0.141 ... radians. And hopefully you can see what this is going to be now. 1, 2, 3, and then this section right here. Well, that right there is simply pi. It's pi. So half a circle is pi radians. Half a circle is pi radians. That's really, really important. And that means if we were to go right around a circle, it's 2 pi radians. Again, super duper important. Okay. The next thing that we're going to do now is kind of just look at this animation. And this animation is just going to go over what I just spoke about. And then, so we've got this radius r. Then this r will come up. And as you can see, it's right there. And that, my friends, is 1 radian. And then it's a very slow animation. Now we've got 2 radians. Now we've got 3 radians. And then it's going to go there, pi radians. And then it's going to say, well, if that half a circle is pi radians, the full thing is going to be 2 pi radians. And right there, we have what we just showed using this right here, this 2 pi radians for right around a circle. So now we've got 2 different ways about thinking about measuring angles. You've got degrees and you've got radians. One has 360 degrees, one has 2 pi radians. It's also important to know in terms of the units for radians. Sometimes you can just write rad. Sometimes you write this right here, this superscript with a C, but 9 times out of 10, the vast majority of the time, you don't put any unit at all. And the reason for that is because the radian measures the ratio of the length of the circular arc to the radius of the arc. And since radian measures is the ratio of a length to a length, the result is a pure number that needs no unit symbol. If all that doesn't make any sense, all you need to know is that you do not need to put a unit on radians. You just leave it most of the time. Okay, so with all that being said now, let's begin just to slowly work through our notes here. Okay, so radians. We usually measure angles in units of degrees. Another unit of measure for angles is radians. 1 radian is the angle subtended at the center of a circle by an arc that is equal to the length to the radius of the circle. Often the symbol for radians, this, is omitted. For example, 45 degrees is written as pi on 4 radians rather than pi on 4 with that C there as well. So these mean the same thing, we just don't put the unit there. Okay, let's now talk about the unit circle. So consider the unit circle, a circle of the form x squared plus y squared equals 1. So what that means, it is a circle with a radius of 1 here. And as you can see, we have drawn in 1 radian. So this length right here is r. And because that's 1, they've gone 1 there. And because we know the circumference of the unit circle is equal to c equals 2 pi r, so the circumference equals 2 pi r is equal to 1, we can say that the circumference is equal to 2 pi. Okay, let's now talk about how we can convert from degrees to radians. Since we know there are 360 degrees in a circle and there are 2 pi radians in a circle, we can use this to convert between the two units of measure. Okay. So the aim of the game here is to see if we can get to find out what 1 degree is. Okay, so if I divide this side by 360 and I divide this side by 360, these 360s will go away, which means I'm left with 1 degree here. And then on this side, well, 360 can be divided by 2, which will give me 180, and 2 divided by 2 is 1. So that means I'm going to be left with pi on 180 radians. This is going to be helpful. Let's now see if we can figure out what 1 radian is. So that means I'm going to divide here by 2 pi, and then on this side I'm going to divide here by 2 pi as well. This will cancel with this, leaving with 1 radian here. And then on this side, this will cancel, leaving me with 180 on the top. It will be 180 over pi, and that would be my answer. So these are two very important things that we have discovered right here, and we can use these when we are going back and forth, or when we're converting from degrees to radians and radians to degrees. So if we start with degrees and we want to go to radians, what we do is we multiply by pi on 180, or if we start with radians and we go to degrees, we times by 180 over pi, and those are deciphered. These numbers are gotten from right here. Okay, let's now see if we can go through some examples here. So it says, convert the following from degrees to radians. So we have 14 degrees here, which we have to turn into radians. So you would say that we are starting here. We're starting with degrees. We need to go to radians. That means I'm going this way. So I'm going to be timesing by pi on 180. So let's see if we can do this. I'm going to times by pi on 180, which is going to be 14 pi on 180. And now what I'm going to do is I'm going to simplify. So this is a very important step. Both of these can be divided by 2, leaving me with 7 here and leaving me with 90 here. So that means my final answer here is going to be 7 pi on 90. Let's now go to the next one. So again, we're turning this into radians, and remember radians don't need any units. So I'm going to times it by pi on 180, which is going to give me 480 pi on 180. Okay, so the only hard part here is really simplifying. The rest of it's pretty easy. This zeros will go away. Both of these can be divided by 6. 48 divided by 6 is 8. Sorry, 48 divided by 6 is 8, and 18 divided by 6 is 3. So that means my answer is going to be 8 pi on 3. Let's go to the next one. So I'm going to times by pi on 180. Now I've got a negative here, but that's no worries. You just take it over. So nothing changes. It's just going to be a negative answer. This will cancel with this. Both of these can be divided by 6. Negative 2 pi on 3. Again, this is negative, but that's no worries. That just means our answer is going to be negative. (42) and 180. What are they both divisible by? Let's think. What about 6 again? 180 divided by 6 is 30, and 42 divided by 6 is 7. So that means my answer is going to be negative 7 pi on 30. Perfect. Let's now zoom out and answer these questions right here. So now it's asking us to convert from radians 2 degrees. So if you needed to, you could look up here and you could say, all right, this time I'm starting with radians and I'm going to degrees. So that means I'm going to be using this one right here. So I'm going to be multiplying by 180 on pi. Multiply by 180 on pi. So now you just have to be careful when you simplify. So this pi is going to cancel out with this pi, and I'm going to be left with 4 times 180, which is 720. Don't forget your units here. You need that degree symbol. Right here, I'm going to do the same thing. Be careful when you're simplifying. So you can imagine this is where people mess things up. 180 and 6, that can go to 1. 6 divided by 6 is 1. 180 divided by 6 is 30. Now I just have to do 5 times 30, which I know what that's going to be. 5 times 30 is going to be 150 degrees. Now the next one is negative, but do not fear. We know what we're going to do here. We're going to times it by 180 on pi. Let me get my... That will cancel with that. This 3 divided by 3 is 1. 180 divided by 3 is going to be 60. So that means I'm going to be left with negative 5 times 60, which is going to be negative 120 degrees. Last one. So I'm going to times this by 180 on pi, and that means I'm going to be left with this. We'll go with that to make it 30. This pi will go around with this pi, and I'm going to be left with negative 7 times 30, which will be negative 210 degrees. Perfect. All right, so let's now come here and let's talk about some important angles. So these are angles that you just need to memorize, and I'm going to be showing you how they fit into our unit circle here. So the diagram shows a unit circle, i.e. a circle of radius of 1 unit, and these are things that are just going to come up over and over again. So these very important angles that you need to know. The first one we're going to look at is 30 degrees. You need to know that 30 degrees is pi on 6. So if we wanted to, we could go through that whole conversion thing, but I just want you to memorize in your head that 30 degrees is pi on 6, and that would be right here. Next, 45 degrees is pi on 4. 60 degrees is pi on 3. 90 degrees is pi on 4. Sorry, pi on 2. What am I doing? Pi on 2. 180 degrees is just pi. This is 3 pi on 2 for 270 degrees. And then finally 360 is 2 pi. So it's important to realize here that this is also 0 and 2 pi. And then you could keep going around. It's also 4 pi. It's also 6 pi. If we just keep going around that circle, and we're going to see that later on. But for now, let's just think of it as 0 and 2 pi. Okay, the last thing that I want to go through here is how to use your calculator to convert from radians and degrees, how to convert between them. There are instructions here if you ever get lost. But right now, I'm just going to show you how we can use our CAS to do this. So the first one we've got, let me just bring it down. The first one we've got is 136.4 degrees, and we need to turn that into radians. Now, the first thing that you want to take note of here, let me just set myself up. What you want to take note of here is that if your calculator is already in radians, the easiest way to do it is literally just to type in your number, put in your degree sign, and then if you just hit enter, it gives you the answer as a radian, no fuss. So you just have to hit enter. The long way to do it, and the way that these instructions show you how to do it, is to do it this way. You would take this, then you would hit this book right here, and then what you do is you type in the letter D, and it takes you here, and you type in DD. Then you hit enter, then you hit enter again, and do you see how it gave it to me as, whoops, sorry, we wanted it as radians. I just gave it to you as degrees. That was my bad. we hit there, we want radians. So you hit R. You hit R, where's R? There it is. Then we scroll down a bit. There it is, rad. You hit rad, hit enter, and there's our answer right there, 2.38063. The other one we wanted is 84.1. So again, the easy way to do this is simply go 84.1, hit enter, and it, whoop. So before you do that, you have to put in the degree symbol. Hit enter, and it gives you out the radian, and that's because the calculator is in the radians already. The long way to do it is you have to do this, then you have to hit the book. It's already here, but let's just say we were somewhere else. You have to type in the letter that you're after. So in this case, R. It takes you to R. You need to scroll down a bit. You go to rad for radian. You hit enter. You hit enter again, and it gives you your answer out. Now, if you want to do it for degrees, so here it's 11 pi on 9. So let's just come over here for a second. So we're going to start this time with the radian. So I'm going to go, let me just open up some brackets here. 11, whoops. Control divide, 11 pi on 9. So we have 11 pi on 9, and that's in radians. And we want to turn it into degrees. The way in which we do this is you just hit this book, you type in the letter D, DD, hit enter again, and it gives it to you right there. In the notes here, it takes you through one more step before you do this. What it tells you to do is actually it actually says that you should put the unit for radians here. So hit that, there's the radian one, hit enter, and then it gives it to you. But because the calculator is already in radian mode, there's no need to do that, I feel. And as you can see, you get the same answer out. The last one, 5.18, so that's a radian. 5.18, so that's radians. We want to get it to degrees, so we just go book, there it is already, hit enter, there it is, 296.792, and that's it. That's how you go about it. So hopefully you wrote those all in, and yeah, that's all I really want to say. So hopefully you feel comfortable using your calculator. Hopefully you know about these very important angles that you need to know, and hopefully you feel comfortable in converting from radians to degrees to radians. And you also just have a good understanding of what radians are. And with that, I will say goodbye.